Hello, I am Sunita. Welcome to my class. Here I am going to explain Gpstr 2017 Maths and Science Solved Question Paper Part 2. This is my third class. Those who not saw first and second class, first see this one. Then you can follow easily. You can follow the third class. In this session, I am going to discuss some of the few science question answers in detail. I am trying to explain in detail because this is very important question. They may ask in any competitive exams. Let us consider next question. At absolute zero temperature, room temperature and very high temperature, a germanium crystal acts respectively as how the germanium crystal, how it will act at different temperature. They are asking the question. They are given the option here. Option A, conductor, insulator, semiconductor. Option B, conductor, semiconductor, insulator. Option C, insulator, semiconductor, conductor. Option D, semiconductor, conductor, insulator. Let us discuss in detail. Germanium, atomic number of germanium is 32. Then here electronic configuration of germanium is argon 3d10 4s2 4p2. Then let us consider atomic structure of germanium. This is the atomic structure. Here you can identify 1, 2, 3, 4 valence electrons in germanium. What is mean by valence electron? The electron present in the valence shell, we will call it as a valence electron. What is mean by valence shell? The outermost orbit of an atom, we will call it as a valence shell. Then the electron present in that shell, we will call it as a valence electron. Then one important thing you have to remember, these valence electrons only, they will involve in bonding. Then here also this 4 valence electrons of germanium, they are responsible how germanium, why it will behave sometime as a insulator, semiconductor, conductor. Let us discuss in detail. Now consider one more diagram, energy level diagram. Here the arrow mark, it will show an electron energy. Then this dotted line, it will indicate band gap. Then here you can identify two different types of band. One is valence band, another one is conduction band. Let us consider first case, how germanium at 0 Kelvin, how it will behaves. Already you know in germanium you are having 4 valence electrons. Now at a 0 Kelvin, otherwise at a 0 temperature, the germanium, in germanium the valence electrons, they will be in valence bond only. They will not acquire any energy. Then they will not move to the conduction band. Then germanium at 0 Kelvin, the valence electrons, they will be in the valence band only. They will not come to the conduction band. Then therefore it will not conduct electricity. And one thing you can identify, there is a large gap between the valence band and conduction band. A pure germanium crystal at absolute zero has electrons only in the valence band. Already I explained, the electrons, they will not provide any energy. They will be remain in the valence band only. They will not come to conduction band. No electrons in the conduction band is there. It acts as an insulator at 0 Kelvin. Therefore at 0 Kelvin, germanium, it will act as an insulator. What is meant by insulator? Insulator is nothing but it will not allow any electricity to pass through it. It will call it as an insulator. Therefore germanium at 0 Kelvin, it will act as an insulator. One more important thing you have to remember here, there is a large energy gap between conduction band and also valence band at 0 Kelvin. Then when the temperature increase, when the temperature come to room temperature, then the energy gap between the conduction band, valence band, it will be decreased, and it will acquire some energy. Because of that energy, the valence electron, they will jump from valence band to conduction band. Not all the electrons they will move, only few electrons they will move from valence band to conduction band. Then these electrons, the movement of electron from valence band to conduction band, then they will responsible for the conduction of electricity. Therefore, at a room temperature, germanium, it will act as a semiconductor because the presence of valence electrons, they will move from valence band to conduction band. What is mean by semiconductor? Semiconductor is nothing but the conductor. It will the element, it will allow electricity to pass through it. Partially it will allow electricity to pass through it, because here not all the valence electron they will jump to conduction band. Only few valence electron they will go to the conduction band. That few electrons they will involve in the conduction of an germanium. Therefore, at room temperature, the germanium, it will act as a semiconductor. Then one more thing you have to remember here, at a room temperature, the energy gap between the conduction band and valence band, it will be decreased compared to insulator. Therefore, the valence electron, they will acquire some amount of energy, then easily they can jump from valence band to conduction band. Then the third case, at very high temperature, you can see the overlap between the conduction band and valence band. Then there is no energy gap between these two bands. Then all the valence electron, they will be present in the valence band. They will move to the conduction band. Then all the four valence electron, they will responsible for the conduction of an electricity. Therefore, at very high temperature, germanium, it will act as a conductor. What is mean by conductor? Conductor, it will allow all electricity to pass through it. We will call it as a conductor. Then listen here, germanium is a semiconductor. It conducts electricity at room temperature, a temperature higher than room temperature. Then in semiconductor, the valence band and the conduction band do not overlap each other, but at higher temperature, the electron from valence band and cross the conduction band. Here they are telling, in semiconductor, in this case, the germanium crystal, you can identify the conduction band and valence band, they will not get overlap at room temperature, but as the temperature increases, the valence band and conduction band, they will get overlap. Therefore, at higher temperature, the germanium crystal, it will behave as a conductor. These points you have to remember. Therefore, correct answer for this question, germanium crystal at 0 Kelvin, it will act as an insulator, and at room temperature, it will act as a semiconductor. Then at higher temperature, it will act as a conductor. Now let us consider next question. Antibonding molecular orbitals are represented by, how we can represent antibonding molecular orbitals? Option A, sigma pi. Option B, sigma star pi star. Option C, sigma pi star. Option D, sigma star pi. Let us discuss these new orbitals means these antibonding orbitals arise from the linear combination of atomic orbitals to form bonding and antibonding orbitals. Let us consider here consider this diagram, energy diagram for two pi molecular orbitals in a typical pi bond. Already I mentioned, when two atomic orbitals, when they combine to form a bonding and antibonding molecular orbitals. Always you have to remember how antibonding molecular orbitals, how it will form means two atomic orbitals combines to form an even bonding and also antibonding molecular orbitals. Here bonding molecular orbitals, they are having lower energy, therefore they will settle at the lower level. Then antibonding molecular orbitals, they are having high energy, therefore they will be at the up. This arrow mark, it will indicate the energy level. It will show the increasing order of energy level. Then the electrons, they will occupy in the lower energy level. First they will occupy in bonding molecular orbitals, then they will move to antibonding molecular orbitals. Then so they are the first to fill up by figuring out the molecular orbitals. it is easy to calculate the bond order. What is the help of this formation of bonding and antibonding molecular orbitals? This bonding and antibonding molecular orbitals, they will help to calculate the bond order. Then next one, coming to this picture, you can identify two sigma bonds. They combine to form a sigma star anti-bonding molecular orbitals. Then two pi atomic orbitals combines to form a pi star molecular orbitals. Therefore, correct answer for this question is antibonding molecular orbitals are represented by sigma star and also pi star. This is very important concept. I can't explain this concept within our 5 or 10 minutes. When I am making the concept based videos, this antibonding, then bonding, then molecular orbit, I will explain in detail. Let us discuss next question. As we move from earth pole to equator, the acceleration due to gravity g. As we move from earth pole to equator, how acceleration due to gravity, how it will be vary? They are asking the question. Options are decreases, option B increases, option C first increases then decreases, option D first decreases then increases. Let us discuss the answer. Acceleration due to gravity and the surface of the earth is given by the formula small g, it will be equal to capital G capital M divided by r square, where r is the radius of the earth, capital M is the mass of the earth, capital G the universal gravitational constant. In the above equation, small g, capital G and M are constant, but r varies due to the shape of the earth. R is nothing but radius of the earth. It will be vary from place to place. We know that the shape of the earth is not a perfect square. Shape of the earth is not a perfect square. It is in the form of a oval. It is flatted at the poles. It will be flat at the poles and bulged at the equator and bulged at the equator. So the polar radius is smaller than the equatorial radius. Let us explain here. Listen here. Polar radius is nothing but the distance between the center of the earth to the pole. The polar radius, it will be less. Equatorial radius means the distance between center of the earth to the equator. The polar radius, if polar radius, it will be less, therefore the object on the pole, it will be attracted towards the earth, because the earth is having gravitational force. It will attract all the object towards itself. Therefore, at the poles, the earth, it will possess more gravitational force. Therefore, acceleration due to gravity, it will be more. At the equatorial level, equatorial radius, it will be more. As the radius increases, the distance between the object to the earth, it will be earth center, it will be more. Therefore, the earth is having less gravitational force compared to with respect to pole. Therefore, acceleration due to gravity at this case, it will be decreases. Hence, G is slightly more at the poles than the equator. Thus the value of G on the earth is maximum at the poles and decreases as we move from poles to the equator. For this reason, as we move from pole to the equator, acceleration due to gravity, it will be gradually decreases. At the pole, it will be maximum. At the equator, it will be goes on decreasing, because the distance between the pole to the earth, it will be less. The distance between the equator to the earth, it will be more. Earth gravitational force, it will attract the object. Those objects nearer to the earth, they will attract more compared to the object far from the earth. This is nothing but acceleration due to gravity. For this reason, as we move from pole to the equator, acceleration due to gravity, it will be decreases. Correct answer for this question is decreases. Let us see next question. Potential energy of a body at a certain height depends upon the Option A, mass of the body only. Option B, height of the body only. Option C, mass and volume of the body. Option D, mass and height of the body. Let us discuss the answer. First, we will see what is meant by potential energy. The energy possessed by a body due to its position and shape is called as a potential energy. Potential energy is nothing but the body, it will possess an energy due to its position. Consider here, the stone is raised to a certain height, and due to its position, this stone, it will possess a potential energy. Then consider one more example. This is the spring. If you press the spring, due to its position, it will possess a potential energy. One more example, stretch bow. When you stretch the bow, then due to its position, it will acquire a potential energy. Therefore, potential energy is nothing but the energy possessed by a body due to its position or shape is called its potential energy. Potential energy is given by the formula mgh. Listen here, the potential energy of a body in the raised position depends upon the following two factors. Then listen here, potential energy, it directly depends upon the mass and also height. As the mass increases, potential energy also increases. As the height increases, potential energy also increases. The mass of the body, greater the mass of the body, greater is the potential energy of the body. Consider this example. If the mass of the stone increases, then the potential energy possessed by the stone also, it will be increases. Therefore, mass and potential energy, they are directly depends upon each other. If mass increases, potential energy also, it will be increases. The next one, its height above the ground, higher the height of the body, greater is the potential energy. Consider here, consider in this example, the blue skyer compared to this yellow skyer, he is in higher height, then he will possess more potential energy compared to this person. Therefore, the potential energy of an object, it will be vary with mass and height. If the mass and height, it will be more to a certain height, then potential energy of that object, it will be vary. Therefore, correct answer for this question is potential energy of a body at a certain height depends upon both mass and height of the body. Next question. Eka aluminium, predicted by Mendeleev, later called as option A, silicon, option B, titanium, option C, gallium, option D, zinc. First we will see what is Mendeleev periodic law. It states that the properties of elements are the periodic functions of their atomic masses. According to Mendeleev, he arranged the elements in the order of their increasing atomic masses. It means the properties of the elements depends upon the atomic masses. He concentrated only on the atomic masses, and the elements are given a position in the periodic table on the basis of their increasing atomic masses. Mendeleev, he concentrated only on atomic masses. He arranged the elements according to the increasing order of their atomic masses. According to him, Mendeleev named unnamed elements are Eka boron, Eka aluminium, Eka silicon, which are later replaced as scandium, gallium, germanium respectively. After Mendeleev, so many scientists, they improved the periodic table. Then they started arranging the periodic table according to their similar chemical and physical properties. Later, finally, they arranged the periodic table according to the increasing atomic number. Presently, what we are using the periodic table, it will be in the order of increasing atomic number. Then later, when they are started discovering the new elements, then Mendeleev what he considered, he arranged the elements in the increasing order of their atomic masses. But some elements they are not positioning properly. Then later the scientists changed their names according to their convenient increasing atomic number. Then they changed the elements and Eka aluminium is known as gallium and Eka silicon is known as germanium because gallium is similar in properties to aluminium. Then one next to it, and germanium is similar in property to silicon and one next to it. They are showing the same properties, then they are given the name. Therefore, correct answer for this question is gallium, Eka aluminium. Later they given the name gallium. Now presently what we are using periodic table, it is arranged in the increasing atomic number. That one you have to remember. Thanks for listening my class. Please send me your valuable feedback. If you have any doubt in any question, you can contact me. Whatever the question today I am discuss in detail, please study in detail. And also some of the concept I explained in detail. If you need more detailed explanation for a particular topic, suggest me the topic. I will make a video depends upon one particular topic in detailed explanation. Here I am going to discuss only the question answer in the form of a multiple choice question. Later I am going to discuss in terms of a concepts. Thank you one and all.